Hey guys, Rochelle here, bringing you another gaming video. Today we're gonna play some GTA 5 and we're gonna kick some...
Rochelle!
Yeah?
You got your homework done? I'll take it from your silence, that's a no. Get it done.
Okay, Dad. Yeah, we'll do that later. Oh my god. Who are you? I'm you, from the future, and you're about to make a grave mistake. Yeah. Whatever. It's not working. What? No, dude, I'm serious. Get out the calc book. Yeah, I don't know how to do these problems. Then listen up, kid, because you're about to get some knowledge on U substitution. Alright, so, U substitution. So, this is an amazing tool to help us solve integrals. What it does is it lets us change the variable of the integral so that we are able to evaluate the expression. For example, we can use the integral of 2 times the quantity of x minus 2 to the third power. Now, if we wanted to use U substitution to solve this problem, the first step we want to take is to find the innermost value of the integral. Now, this usually falls in between, say, a set of parentheses. So in this case, our U value would be quantity x minus 2. Simple enough. This is what we will replace with U. But wait, if we have a U variable, we can't keep the dx. So we need to change that. And how we do that is we find the variable du. Now that's super simple to find. To get du, all we have to do is take the derivative of u. So in this case, we would get du equals 1 dx. Alright, so now that we have our new variables, let's relabel the problem. So before, we had the antiderivative of 2 times the quantity of x minus 2 to the third power dx. Alright, so now when we replace that, we'll get the integral of 2 times u to the third du. Well, now we know that it's only 1 du and not anything else attached to it, because when we try to get dx by itself in this equation down here, all you have to do is divide by 1, and as we know, dividing something by 1 keeps it the same. Alright, so now that we have this integral, it becomes a lot easier to solve. Alright, so what I just did, that I was too lazy to rewrite because my camera was rotated the wrong way, we took du and we plugged into our equation the u variables in our integral. So we ended up getting the integral of 2 times u to the third du. And then, as you know, we integrate, so we raise the power by 1, and then divide our constant multiplier by that value. So we ended up getting 2/4 u to the 4th plus c. And then we can simplify that to be 1/2 u to the 4th plus c. Then it's simple enough as plugging back in your x variable, 1/2 times quantity x minus 2, because x quantity minus 2 equals u, to the 4th power plus c. And you can easily find x through your answer right there. And that is how you use U substitution to solve an integral. Alright, so let's try another problem, another example. This time we're going to be using trig in our integral, and it's basically the same thing as what we were doing before. So to find u, it looks a little complicated because we have a lot of variables in parentheses, but it's not too bad. So what we're going to do is we're going to rewrite this integral. because what we have right here also equals this. We have cosine times 2x all to the third power. So we could put that in parentheses, and that equals the same as this. Then times sine of 2x dx. Now it makes it a lot easier to find our u, because inside these parentheses, this is where our u is going to be, because there's the most, I don't know, action happening to it. So we know that u equals cosine of 2x. That would mean du equals sine of 2x times 2 dx, which we can simplify to be du equals 2 sine of 2x dx. So now it's time to substitute in our u values in our integral. So we have our integral, and then we have u to the third power. Now for du, we want du to equal sine 2x dx. So all we have to do is multiply by 1/2, and then we'll have 1/2 du equals sine of 2x dx. So now that we know that this has to go into our integral as 1/2 du. Now it's simple enough, we can just throw this constant multiplier to the outside of the integral, so we get 1/2 the integral u to the third du, and then we integrate. We raise our power by 1, so we get u to the fourth, and then we need to divide our constant multiplier by 4, so we get 1/2, that's 2, I promise, times 1/4 plus c. And then we can simplify that out to be 1/8 u to the fourth plus c. And that's our answer until we replace u back with our x values. So we can just plug it in, 1/8. Remember what u is, we have cosine of 2x times cosine of 2x to the fourth power plus c. And that's it. You're done. Alright, so we're going to try one more problem, and we're going to use the integral of x times the fifth root of 3x squared plus 1 dx. Alright, so first things first, we're going to make this problem a little more simple for ourselves. We're going to change that to x times quantity 3x squared plus 1 to the 1/5 power dx, because we know that if we have root 5, that's also equal to raising it to the 1/5 power. Next, we're going to find u. U is going to be our inside value of 3x squared plus 1. And then to find du, all you have to do is take the derivative of that, and you will get 6x dx. Alright, now all we have to do is plug that in to our integral, which is as simple as u to the 1/5 du, but we need to make sure that we take into account that du doesn't equal x dx, we need to divide this by 6 first. So we're going to get 1/6 du equals x dx. So that means we'll have that constant multiplier of 1/6 on the outside of that integral. Alright, and then your life is made pretty simple. All you have to do is raise the power by 1. So we're going to get 1/6 u to the 6/5 divided by 6/5 plus c. Now this looks really messy, I know. Let's put some parentheses around that. Instead of dividing by 6/5, we can also multiply by 5/6. So 5/6 times 1/6 and we can replace the u back with our x variables, and we'll get 3x squared plus 1 to the 6/5 power plus c. All we have to do is multiply these two multipliers together. We'll get 5/36 times 3x squared plus 1 to the 6/5 power plus c. And that is it. Now, some common mistakes that people might make when doing u substitution is they may forget that they have to divide or multiply du by a constant multiplier to get it to equal x dx, and then they will just plug in du and then they won't get the right answer. So if there's anything next to this, you'd have to divide it. And also, some simple integrating mistakes that people make is they forget to add c, which is super important because when you are taking the integral of an equation, you do not know what that last value is, and that is the only way we can properly represent it. So yeah, thank you for watching my crappy calculus final on how to do u substitution, and I hope you learned something today. Bye.